Today's lesson is all about electronics, and by the end of it you should know kind of what exactly is electricity, how we use it to power all of the devices around us, where do we get it from, and some of the important applications. Also, there's a lot of activities in this lesson, so it's really hands-on. What I'll try and do today is show you guys maybe the basic errors people make when they're putting together circuits, simple ways to do it, and some tricks for the teachers. Explaining electricity to kids can be quite difficult, but as always you have that paragraph underneath your slides. Feel free to fall back on it, and there's also some good YouTube videos. The basic concept we want to get across is just that electricity is the movement of electrons from atom to atom. After that we can jump back up to the micro scale and we start looking at examples like this. So our first most simple circuit is simply a battery and an LED. An LED works a small bit different than a traditional light. A traditional light has a filament that gets really, really hot, and as it gets hot it gives off light, the same way as when you look at a log of turf burning, it's red instead of brown. What we do though, what's important, and you'll see me do it there, is LEDs, like a normal bulb, have a positive and a negative. So when we take our battery, we might put it on one way and it works lovely, and just by turning the LED around it doesn't work at all. So that's the first kind of tip for today, is if it doesn't work one way, try it the other way around. So very simply you might explain to the students that electrons are leaving the battery, flowing up the wire through the LED and back into the battery. The next activity is all about building circuits with different components, and so we have our box components here, and this is a rough guide, not necessary but can be handy for kids. So what's really important is to get the idea of a circuit across, so it has to start and go through each component and back again. And kids might even be familiar with the idea of a short circuit, and a short circuit is when the electricity goes through and kind of takes a shortcut back to your battery rather than going through the components you intended it to, and I'll show you what that means now. So luckily Play-Doh is conductive, so we have our battery, our leads, hold on to this, something that's important is not to inform the kids about touching the battery off itself. So if you connect the battery to itself, it will let a lot of the power out quickly and it'll also heat up. But if you tell them that it's going to heat up and that it kills the battery, the first thing they'll do is mess around with it. So maybe a good idea for the teachers is to hold on to either the batteries or the leads until the kids are finished putting together the first circuit, so that they can't waste it. So the guides here mean you can go like this. What's really important is that only the component bridges the gap. So if, for example, the Play-Doh was touching any bit at all, then it's not necessarily the legs of the component that make the gap. So make sure there's a really nice defined gap between them. Put in our component. There we go. One thing to be wary of is, again, the direction of your battery matters. So if I put it in like this, I get nothing. It can be quite troublesome to explain to children the difference between positive and negative, because it's difficult to tell on the LED. So the easiest thing to do is just try it both ways. And now, so this is when we begin to add more components. So next thing we might add is a switch. So the same way as before, we want to make sure that the only thing that bridges the gap is the actual component. Our switch. Now, and as before, There we go. So we have the electricity going from a battery through our LED into the switch and back to the battery. What the switch does is it acts as a connection between these on and off. So by making and breaking the switch, you can turn it on and off. Next component then is a buzzer. I would highly recommend, especially as a teacher, not to hand these out until you're ready. If this is one of the first components that you hand out, you will have your head wrecked. Not to give out about the kids or anything, but it's a lot of fun, and so they're going to do what kids do. So we have our buzzer, same as always. Make sure it's the only thing that makes the connection. To run through again, so when you're building your Morse code machine, in the early parts of this, it's important to just get the kids know the concept of going from Play-Doh to Play-Doh without touching. But to make a really good Morse code machine, you're going to want to make sure you use kind of as little Play-Doh as possible. Perfect. So at the end of that lesson, the children should know about electricity, what exactly it is, how we use it to power the world around us, and they should be able to build simple circuits and understand the idea of resistance and using different components to achieve different tasks. So by building up really simple components like lights and buzzers, we were able to actually create a machine that uses electricity to communicate with one another, Morse code. As always, the questions for next week's lesson are in the slides, and thank you very much.